So my name's Sophie. I'm a research assistant and a master's student at Durham University within the northeast of England, and I'll tell you a little bit about the ITCHES project that we're currently working on. So just a little bit of background. It's a UKRI funded EPSRC research project, and it combines immersion cooling of our high performance computing data center, as well as heat storage and reuse, looking at using abandoned mines as a thermal battery. So a little bit about our motivation and objectives. So initially growing data center energy demand. So across the UK and globally, got a lot more data centers and they're experiencing exponential growth. In the UK alone, data centers account for almost 10% of total electricity use, and projections suggest this is going to rise even further as computational workloads expand. So we've got things like AI, ChatGPT, and research by McKinsey shows that cooling accounts for nearly 40% of data energy center consumption. So it's estimated that data centers consumed 55 to 80 terawatt hours in Europe in 2023, and that includes 4 to 8 terawatt hours within the UK. And the carbon emissions cost of a data center is about 0.1 tonnes per megawatt hour. Again, cooling accounting for 40% of a data center's energy usage. Additionally, we've got the carbon effects of heat in space and water. So within the UK, it's almost 50% of total energy demand for heat. And we've got a lot of post-industrial sites, particularly within the northeast where we're located. As many of you'll know, there's about 23,000 disused mines in the UK, most of them flooded, and a quarter of all homes are built on top of mines with temperatures from 12 to 25 degrees within those mines. Additionally, combining these together, we've got the opportunity to capture the waste heat from the high-powered computing centre that we've got, as well as potentially store and reuse it within the abandoned mines that we have underneath the campus. So our objectives for the project are assessing our seasonal heat storage potential, identifying optimal seams and locations, evaluating future integration into any potential heat district networks that the university might have planned, as well as teaching and research integration as well. So a little bit about our high-powered computer. So it's housed within the Earth Sciences building. It consists of around 320 nodes, each with 16 cores, and it's about 128 gigabytes of RAM. So at full computational load, it can dissipate up to 2 megawatts of thermal power. And that's about the equivalent of heating around 40 homes. During off-peak hours, or when the outdoor temperature is cooler, cooling can be done using ambient methods. So we've really got this, as you can see from this blue line here, which is quite a good indicator of cooling. You've got quite significant cooling in the summer, where obviously the heating demand isn't as much, and then lower cooling demand in the winter. So storage would be great to be able to put these together. So our system includes both a Hamilton cluster and a Cosma 5 system. It's quite a significant sort of university scale computing infrastructure. And we initially were cooling it via water, like an air cooling water system. We're installing this month Immersion liquid cooling, which can capture nearly 100% of the heat produced and sort of produce liquid that's up to 40 degrees. So that's kind of a lot more useful for storing this heat underground. So a little bit about the subsurface and the abandoned coal mine workings underneath the campus. So under our campus, we've got two main techniques that we used. So room and pillar mining, where there's large open spaces, and also longwall mining as well, where it's sort of a long face of coal mined progressively, and these are abandoned coal mines. So they've both kind of left quite distinct underground features. So we've got the larger stable void spaces, which are quite good for, a large volume of water that's stored underneath the ground, as well as some collapse zones known as Gulf, where it's quite a compacted zone. It's highly permeable, so it kind of still allows that fluid movement, but it's got potentially more unpredictable pathways for heat flow. We're also working with some abandonment plans. So abandonment plans only became mandatory from 1872. However, they're not all particularly complete. Not all the records are complete. So we've kind of georeferenced these abandonment plans, and hopefully we have a decent view of what the subsurface actually looks like. And in terms of thermal energy storage, it's insulated underground, so it's remaining a stable temperature. So it's better for heat storage than sort of above the surface. So a little bit about Durham, the subsurface under Durham University. So we have two seams that have been worked. The Hutton seam, which is a little bit shallower, which has been mined from 1858 to 1908. So some abandonment plans may not be present. So it's 62 metres below ground level, about a metre thick, and about 35,000 metres cubed of extracted coal there. And then we have the Busty seam beneath it. So that's been mined from 1870 to 1935, 145 metres below ground level and closer to 2 metres thick in places, with 800,000 metres cubed of extracted coal. And we've been looking at areas where the two seams overlap because we're looking at a doublet system. And the geology of the area, it's obviously carboniferous. We've got some sandstone and clay interlayering the two worked seams. So again, for the project, we propose setting up a doublet well system. So we're looking to separate the injection and the abstraction points via a long pathway, and it's vertically. We're looking to separate them. So in our case, the injection well hopefully will be allowed to heat water the heated water to be pumped into the flooded mine workings during the warmer months, and then potentially reversed during the winter to retrieve the warmed water. So there was quite a few considerations when trying to choose the exact location for drilling, which is kind of denoted by the star here. So location of overlap so that we could have a doublet seam so that we haven't got excessive piping above ground. But at the same time, we want to avoid any sensitive structures, so building foundations, underground utilities, and we have some protected woodland on the campus as well. And then we need good vehicle access for drilling rigs, space for our temporary construction zones, things like that. And then we have detailed historical mine maps from the Mine and Remediation Authority for both of the seams. But given the age of them and the sort of timescales in which they were mined and any georeferencing issues we might have had, these may not be particularly accurate. And we also took into account any sort of Gulf zones as well, which we didn't particularly want to we wouldn't be drilling into. So for the initial phase, we're going to install a heat pump for testing purposes. So we want to perform quite controlled experiments, so testing water extraction rates, monitoring any temperature changes, testing the pressure and the flow of the water, and anything else that we might sort of think of. There's quite a few different considerations. So we're going to have a number of sensors at the bottom of the well, looking at, again, water temperatures, flow rates, and pressures. And finally, any potential outcomes that we might have. So I think if the mine water is not flowing significantly, it's going to be ideal for heat storage and reuse, hopefully. But if it is sort of identified as flowing significantly, might be less suitable for heat storage, but it may be good as a replenished heat source for a ground source heat pump. Maybe a cost-effective data center heat removal method, and it may tie in with any proposed university heat networks. But either case, this is in fact a research project, so any data that we get is going to be useful. And some issues that we're kind of considering at the moment, if there's connectivity between the two seams, looking at which further sensors might be most useful, and any sort of inability to hit the target workings as well, which I think may be an issue. So thank you very much. And any questions for me?